All right, so this is the first video for statistics, chapter 1, section 1.1, 1.2, and 1.4. I'll do the video for 1.3 at another time. This one will probably have to be broken up into two videos. Let's see how it goes. If it gets broken up into two videos for this one lecture page, it will not automatically go from one video to the next. You need to, when this one's over, click it to get out, and then click into the next one if it's continued. It will not roll from one straight to the other. Okay. All right. So the purpose of statistics is to gain an understanding of your data. When you're doing a presentation to your company, let's say, you collected all this data. You're not going to put a big list of something on the board for them to just look at a whole bunch of numbers. You want to let them know what happened with the numbers, what did the numbers tell you about what they're talking about, and that kind of thing. So we need to figure out how to present it visually and understand all terminology for it. So let's start with some of the terminology in chapter 1 that we'll use the entire class and make sure we understand these things. Officially, a population is the complete set of all measurements or data that is being considered. A parameter is the measurable characteristic. So in other words, we decide if we want to collect some data about everyone in our class. The population would be our class. And we want to collect eye color, maybe, hours of sleep, that kind of thing, whatever data we're collecting about, and we get a result, and we say 55% of the class has brown eye color. That would be a parameter, the 55%. Any measurable characteristic of the population itself. This many did this many have that. Those numbers are called parameters. You don't hear that much. Mostly you hear statistics. It's because most of the time you're not getting a population, you're getting a sample or select members from the population. Therefore, the results you get are called a statistic. That number that comes out, 65% of something did something, that 65% is the statistics part. That's why you hear more of the word statistic than you do parameter. Most people are giving you sample results. Okay? Variables are the characteristics of interest. Eye color, how many hours you slept last night. These are areas of interest about the population or sample that we're collecting data about. To be able to describe the data, that's a variable. Okay? The description of the data values that went on the clipboard, that's what I say. What are these numbers? These are hours of sleep. These are eye color, that kind of thing. That's the variable. The data themselves are the actual data points, the data values. It could be asking the people in the class their favorite color. So you'd write down yellow, blue, you know, that's what you'd put on the clipboard. So that's the actual data. They can be numbers, they can be words, but that's what the data is. What are you collecting about each individual in a sample or a population? The word datum is a single value. I usually don't use that word. I'd use, say, a data point, a data value. We'll come to find out it actually is represented by just an X. And it's whatever's recorded about each individual member. So when you go to present your results to someone, you're going to organize and summarize. 65% had brown eyes. 62% got 6 hours of sleep last night. And you're going to maybe just have a final total like that, or maybe you're going to have a graph, or you're going to have a pie graph or a histogram or something or other. How do you describe is way you organize and summarize. Inferential statistic is you draw conclusions from this. That's a separate step, and we're going to learn ways you're allowed to do that. Statistics is about, this is what the data says. The inferential part should be very, very carefully used. If you're taking a sample of a population, maybe you can make inferences about the population from the sample. That's sort of what you're trying to do, and there are good and bad ways to do that, and we'll talk about that. So let's say we asked the average hours of sleep from each classmate. Average hours of sleep. Then you think about how many on average they get per night. So, excuse me. So if I have two really big circles here, in the little one, you can talk about a population and sample in a variety of ways. Our class could be a population, and you want to make sure you get a result, a data point from every single student in the class. You can take our class as a sample from a population of the entire college, and make inferences about the population of the entire college, how many hours of sleep they get every night. You want to be careful of how you state it. I would say the population, I'm going to write in the big circle that the population we're drawing from today is all students. I'm going to write this down. Sorry. You'll find I have really terrible handwriting. I'm just going to apologize now. All students in class the first day. That's the population. And then let's say we only take information from people in the first row. So our sample would be students. I'm going to write in the little bubble that's inside the big bubble. Students in the front row. Oops. Okay. So our population is all the students in the class in the first day. The sample that we're going to take are just the students in the front row. Okay, so I'm going to write sample next to that. And then this one I'm writing population next to that. And the data we're going to collect, well, what's the variable I just mentioned? So the variable, let me write that down, is number of hours. Wow, sorry about the handwriting here. Number of hours number of hours, getting there, student sleeps on average a night. So you want to define your variable very well so the students know, your samples know what exactly they're saying and they're responding to. And then you would write down, okay, how many hours do you think you have? And they say 6, and the other person says 5, and the other one says 7.5. And you just, on your clipboard, you write the data down, okay, from all the people in the front row, and you add them all up. We're going to learn how to take the average for the class, so the mean, median, mode, standard. We're going to get to standard deviations and things like that using this data, all the different ways you can crunch through this information that you got. Okay, we're going to add up the total number of students that were in our sample and give some results. Like, let's say our results were 43% of the students had in class get over 6 hours of sleep a night. That might be a summary or a descriptive statistic. When you say 43%, that would be a statistic coming from the sample that we can use as an estimate or an inference about the rest of the students in the class. All right, next page. All right, so when we collect this data, there are different types of data. When you write down things on the clipboard, there is a way to kind of classify the two main types of data. We have quantitative data, Q-U-A-N-T, quantitative data, and we have qualitative data, Q-U-A-L-I-T. So quantitative data consists of numbers that represents counts or measures. Did you count something like the hours? So I'm going to write down, this is the same. We just did hours of sleep. That's that's a number that we can add, subtract. Somebody slept twice as much as someone else, that kind of thing. Qualitative is a categorical data. That means names, labels. That would be the kind of the yellow, like favorite color, yellow, blue. Notice we're not writing down numbers on the clipboard. But you have to be careful when you say that, because what about zip codes, student IDs, phone numbers? These are all numbers that the math operations cannot be performed on. So you can't add a zip code to another zip code and make any sense out of it. You can't add a phone number to another phone number. You can't subtract them. You can't multiply them. These also fall under the qualitative or categorical data type. The quantitative, however, can be broken down into counts versus measurements. So the counts, the quantitative data that is countable is called discrete data. Discrete variables can only assume certain values and no intermediary values. So let's say you're counting people or dogs or boats or something like that. 1, 2, 3, 4. There's no half a person. So full counts, they're called. The other ones are considered measurements, quantitative data that is over a certain interval, is called continuous. So we're talking fractions and decimals, and things that you can have a half of or a quarter of or 0.02534 or something like that. So they would be considered measurements. So two types of data, quantitative, qualitative. The average, so then it says which type of data is average hours of sleep. That's, sorry about the handwriting. Quantitative is the number of hours for sleep. And what kind of, when you say quantitative, you'll have to know what kind. Is it discrete or continuous? Number of hours of sleep. Can you say 5.5? If you can, then it's continuous. Think of a number line. It has the integers that have the main numbers, the whole numbers, but you can have, a half an hour. You can have a 1.5 hours. So those are continuous. If it's on, think number line. It's a measurement. Okay. What would have been a qualitative category? That was a favorite color or eye color. I'm writing this down. Color. Okay. And then what would be an example of a quantitative discrete? If number of hours sleeping is a continuous, what's a quantitative discrete? How many siblings? Sibling number, how many pets, that kind of thing. 1, 2, 3, 4. Anything that you can count. How many books, how many pairs of shoes, that kind of thing. All right. So when we collect this data, it's very important to select your sample the correct way. So if I picked all the people in the front row, that's one way to do it. What if I picked the first 5 people that walked into the door, the last 5 people that walked into the door? I assigned everyone a number and said, okay, every third person is in the sample. There's many ways to get your sample from a larger population, and you have to do it in a correct way that you can That is one important way to make your data reliable. Your sample, if you collect a sample, should be a good representation of your population. So once I decide on my sample, I can do an observational study. We just observe and measure. We don't modify the students. If you just ask them a bunch of questions, you're not really changing anything or doing anything. So that's just an observational study versus an experiment. Experiment, you need a control group and this, that, and the other, where you're applying some treatment to some people and then just observing the effects on everyone. It's a little more involved. So for our purposes, there's just two types: observational study, experiment. Experiment, you have a control group. You're interfering in some way. You're separating them and doing something. And then there's also random sampling. We're just simply doing a random, I'll describe each of those in just a second. So the different types of sampling methods are simple, random, stratified, cluster, systematic, convenience, and multi-type. Let me get to that. So, here's a better description of an experiment. So if somebody wants to know, does exercise prevent colds, and you want to do an observational study, you randomly select your students, you record the data for each student, the amount of exercise they had and the number of colds they had, find if there's any relationship between them. For an experiment, though, you would get your participants, and then you would divide them into a treatment group and a control group. Then you would set a set amount of time, record the amount of exercise and the number of cold each of them have, and then compare the two groups. So let's see. It says for a set amount of time. I would say that's a little vague. I mean, why would you divide them into groups and then not do anything? I think I would make my control group make sure that they had a regimen for exercise. So you knew exactly how much they exercised, and compared that to the group that just kind of exercised on their own. That might be a better description on that one. All right, so all the different ways to sample people. One of them was simple random sample. Every possible sample of size, we plan to draw an equal chance of being selected. So if we were doing this class, I would assign everyone a number, or have everyone put their name on a piece of paper. Let's do two different ways. So put all your names on a piece of paper, draw them, put them all in a bag or a hat or whatever, and mix them thoroughly, draw one name. Mix them thoroughly, draw another name. That would make sure that everyone has an equal chance of being selected for the sample. You can also put a list in a computer and have a computer randomly generate who, pick names themselves. Next page. Stratified sampling. You can group your subjects first. Like all the people in this class, if we went by freshman, sophomore, junior, senior, that would be grouping them first into homogeneous groups or something called strata before the sample is selected, and then you would take some from each strata. So if I grouped you all into 4 groups, and then I took some of each group, okay, so I want to write down group first for the stratified sampling type, and then pick at random students from each group. That's the stratified sampling method. If you do a systematic sample, you would assign everyone a number and then pick, or just pick every 4th one. So it's a way to systematically pick people, no matter what. So it can be less expensive, they say, than true random sampling. Just so like if everyone, as you came in, the door's pretty small, you'd all come in one at a time. And I had in my mind that I was going to pick every third person for my sample. So I'd be counting, as soon as the third person, I would ask who they are, write their name down. Then they go sit down and 1, 2, 3, ask who that is. And these are how I would get a sample for systematic sampling. Cluster sampling. Let's say your data is big. Look at this map, this whole map of Maryland. And these are all the different counties, maybe. I don't know what these little red houses are, but there are a lot of, let's say it's counties. A lot of counties in Maryland. So they're grouped by county. Everything is already grouped by county. To do a stratified, I would have to pick some from randomly selected from each county, and that would be a lot of people. So for clusters, it might be easier to say, okay, everybody's grouped in communities, so group first, just like this systematic. But then you would take all of certain groups. So instead of saying some of each group, you want all of some groups. That's just easier. Okay, that's for cluster sampling. Convenience sampling. Let's say I just took the people that came in first. I took the first 10 people that came in the room, just because it was easier than counting the people that were coming in, and I could get it done right away. So I would just pick the first 10 people that came in because it's convenient to me. Whether that's a good sample of the entire population, I don't know. It's just something that can lead to bias about things. I'm really only getting information from people that are on time or early from class and leaving others out. So I might be able to put this all together. Let's see, I got one page left. Sorry, I'm going so fast, but you can always rewind. Voluntary response samples made up of people who self-select into the survey. If you send out a survey, the people that return it or answer the phone have a strong interest in the topic. So you're not really hearing from people. I don't know about you, but I never answer surveys on the phone. So once you do that, they get your phone number and they'll call more with more surveys. It's just not something I like to do. So you'll never know what I think about things. But if somebody's calling about something and you feel strongly about it, you're more likely to give a response to that. The major problem with this type of sampling is that you cannot generalize your findings out to a larger population because this is really just certain people. So volunteer, if somebody volunteers and let's say somebody in this class volunteered for my sample, okay, and I'm only using the volunteers, I'm not hearing from all the other people. Maybe that's not a good random way to get people, but it's what people do because it's convenient. I would call that a convenient type of sampling too. So for example, a test question might be identify which type of sampling is the following. So you're answering random, systematic, stratified, cluster, voluntary, or convenience. On a test, there's no distinction between the voluntary response and convenience. They're kind of the same thing to me. I guess voluntary would be people that step forward. Convenience is who the researcher picks. So fine distinction on that. All right, number 1 says measure the length of time every 9th person comes into the bank. Well, any kind of there's 9th, that's 2nd, 3rd, whatever, that's systematic. If you're assigning a number and then picking. Pregnancy study in Baltimore randomly selected 15 communities from the metropolitan area, then interviewed all in these communities. So you have to think about that for a minute. You have to assume there are more communities in the metropolitan area than 15 because they randomly selected 15. So that's group first. Do you understand that? There's lots of different communities, they selected 15, and then they took all the people from those 15. The keywords are all and group. What's group and then all? That's cluster. Let's see. The next one says, prepare for her book. She sent questionnaires to 100,000 people and asked them about their relationships. And the people that felt strongly about them and sent them back, I'm going to say that's voluntary. Because they didn't have to send them back, I guess. Yeah, that's confusing, so I probably won't have a test question about that. Choose committee by dividing employees according to rank, and then randomly sample from each group. So we're dividing employees to rank, so that means we're grouping them first, and then when you get some of each group, that's stratified. All right, a journalist goes to the campground and asks people how they felt about their air pollution. Now, think how he's going to do that, or she's going to do that. They're going to walk into the campground and just what? Ask people they run into. So that sounds like a convenience. Okay, the people may or may not talk to them. Somebody may find out they're asking questions and go running over to them, kind of volunteering themselves. So that's why I said it's kind of hard to tell the difference. But I think the way it's worded there, it's convenience. All right, how about randomly calling generated phone numbers? Asked 855 adults which medical condition could be prevented with their diet. They randomly called. I don't know. I'm going to go with random. Yeah. Divide the population into groups, and then take some within each region. That's stratified. All right, and then there are other practices we may or may not get to in class, but if you want to look at them, there's a nice list of things to look at to give you a little more information. You should know what a pie chart looks like, a bar graph. A Pareto chart is a bar chart where the largest, these are separated. It's a bar chart. The bars can go horizontal or vertical. And then the largest is always first in a Pareto chart. And smaller after that. It's good for categorical data. Okay, it says pie charts, bar charts, and Pareto charts are good for qualitative, which is the same as categorical data. Okay, you don't have numbers. It's a little hard to group them together and put it and do any number crunching when you have no numbers. So some of the things that you can do is make pie charts, bar graphs, and Pareto charts. Okay, so those are the pages there's examples of. More examples of sampling and a little bit of ethics on statistics. You really want to ask your questions if you're doing a survey correctly. You don't want people to have leading questions like, what do you believe that milk is fattening? That kind of puts the idea that milk is fattening in their head. So they more likely say yes if you say it that way. If a officer asks if you do illegal drugs, the person asking, nobody's going to say yes, I do illegal drugs. So there's ways to be careful when you really want to sample or not. All right, that's all the time I have. That was everything for day 1.